Ladies and gentlemen, the workshop will begin in 5 minutes. Thank you for your patience. Before we start, please know that if you have any questions for our speakers, you may use the link provided on the screen and fill up the QA form. Thank you. Good day to our audience around the world. Welcome to our international workshop on Trustworthy AI today. We are delighted to have you here. As the world increasingly relies on AI technology to help make major predictions and decisions, it becomes essential that people can trust the process and the outcome of the AI. In today's workshop, we have invited experts in this field to discuss on how are we going to do that. First of all, we would like to invite the General Chair of today's workshop, ITRI's Executive Vice President, Dr. Pei-Zen Chang, to give us his welcome remarks. Dr. Chang, please.
Distinguished guests, ladies and gentlemen, good morning, good afternoon, and good evening. On behalf of ITRI, it's my great honor and pleasure to welcome all of you to join our workshop today. Artificial intelligence is one of the key drivers in the modern technology sector. In ITRI's 2030 technology strategy and roadmap, we particularly focus on the development of enabling technology to drive market-oriented R&D in different application areas. This year, we integrated Trustworthy AI into the roadmap, hoping that AI innovations will become more popular and acceptable to the public with few concerns about its potential risks. ITRI collaborates with the Taiwan AI Action Plan to help industries with their digital transformation. So far, we have seen numerous achievements in fields such as manufacturing, medical care, business services, and autonomous vehicles. For instance, an AI decision support system for founders' images was developed by ITRI to detect diabetic retinopathy. In this system, AI is used to locate lesions and classify severity, providing early screening and diagnosis. However, AI adoption is facing the difficulty of interpreting and trusting the outcomes of AI applications. We can trust AI only if we understand how AI works, why it makes the decision it does, and its pros and cons. This is why we are having the workshop today. By including issues such as AI explainability, ethical issues, and data bias, we hope that more attention will be given to the assessment and the verification of AI, as well as AI-related policies and regulations. I believe through today's discussion and sharing, we can all learn more and get inspired. Thank you for joining us. I hope all participants enjoy today's session and wish the event a great success. Thank you.
Thank you, Dr. Chang, for the kind welcome. And now, our advisor, Digital Minister Audrey Tang, is also going to share a few words with us. Minister Tang, please.
Good local time, everyone. It is my pleasure to speak for the 2022 International Workshop on Trustworthy AI, organized by ITRI and supported by the Industrial Development Bureau of MOEA. This workshop is the first forum in Taiwan for experts from the industry, academia, and government, from both home and abroad, to exchange their ideas on Trustworthy AI. Now, we're also honored to have esteemed guests from the National Institute of Standards and Technology, from Columbia University, and the FIDO Alliance to discuss global challenges and opportunities for AI development. Now, about AI and democracy, many places in the world are seeing conflicts between AI and democracies. Technologies are being misused by dictatorships to monitor and erode democratic institutions, whereas democracies ensure information security and privacy through more and more restrictions and regulations. Nevertheless, these conflicts are not inevitable. Taiwan has invested heavily to facilitate the collaboration in digital technologies in pro-social ways, enabling these technologies to thrive together with democracy. For instance, Uber, upon its entrance into Taiwan in 2015, led to the same controversies as it had in many parts of the world. In 2015, we attempted solutions successfully on the V-Taiwan and the Polis digital platforms, using AI to identify the trends in the attitudes and map to all the participating citizens the connections between their feelings and comments. Now, we reached a preliminary consensus and identified the advantages of the new ride-hailing services while protecting the rights of the drivers. So new policies were then implemented by the government, and this digital democracy method has been used to resolve dozens of controversial issues in Taiwan. As long as AI can be explained and well understood by the people, I think we will come to trust it more as assistive intelligence instead of authoritarian intelligence. And just like the story of Doraemon from Japan, the AI and humans can become complementary and can even be good friends. While humans are always in the main role, AI serves as the assistant to help us accomplish many tasks. Now we are going to set up the Ministry of Digital Affairs with the aim to turn Taiwan into an example of a great democratic and smart nation. AI technologies will be then essential to realize this vision. Trustworthy AI is the foundation to make sure that the AI will be able to balance the needs of humanity and social development. And Taiwan, with our AI development, will become an important partner for democracies worldwide. Taiwan's semiconductor supply chain has always formed a solid ecosystem with our global partners. And in the field of ICT, we have moved from OEM to ODM and established ourselves in PCs, in servers, in cloud data centers, and so on. And with our outstanding R&D capacity and manufacturing technologies, we have become a critical engine for global AI computation. AI algorithms, they're ubiquitous now. The Google search engine, Siri, Facebook advertisement placement, Netflix recommendations clusters, and Uber Eats, they're all driven by AI algorithms. This comes with the challenge, including how to ensure the wider availability, to avoid monopoly by selective agencies, and how to ensure AI applicability to the entire society and humanity. Trustworthy AI is an answer to the aforementioned challenges by ensuring system efficiency, security, transparency, and equality. In the future, AI and digital technologies must be friendly to the whole society and increase everyone's efficiency together. They should empower businesses and the general public equally. And therefore, trustworthy AI will be the foundation for Taiwan to advance digital technologies that support our democracy. And now we're planning to include data altruism, or data for public benefits, as one of the focuses of the Ministry of Digital Affairs. Data altruism refers to the voluntary provision of data by the owners and controllers, using data for public benefits to shape a shared, diversified ecosystem for social development in the form of digital co-creation. Data altruism enables people to use data as a form of digital asset to actively engage in public affairs, facilitate social service innovation, and proactively create social value. And this is the best example of public entrepreneurship that aims for collective prosperity. And Taiwan has been promoting the AI Action Plan since 2018. The results are evident in talent development in industries, laws and regulations, field trials, and mechanism design. For example, we have nurtured tens of thousands of talent who know how to put AI into use in their communities. Foreign businesses have invested in AI infrastructure and R&D here. Relevant laws and regulations are also in place to offer field trials. And all of these are conducive to incorporating AI technologies into the various industries and building an AI together. In the next phase, the AI Action Plan 2.0, our data governance and AI ethics strategies will be important areas of focus. Now, based on the existing foundation, the Ministry of Digital Affairs will continue to enable more businesses, groups, and individuals to enjoy the advantages of AI. And additionally, we will actively engage relevant international organizations to form a network for trustworthy AI, develop internationally compliant AI regulations and standards, and create a diversified and innovative environment for AI development, and we will accelerate the development of trustworthy AI together with all technologies practitioners. The workshop today marks a great beginning. I hope that we are able to have ample discussions about how to build this democracy network, achieve international scale, inspire businesses, academia, and institute, communities, and social groups together, and contribute to the standardization of trustworthy AI. And once again, I would like to extend my appreciation to the distinguished guests from the industry, from academia, and government. My special thanks go to NIST, to Columbia University, and the FIDO Alliance for attending this workshop late in the night. And with this, I wish you a fruitful event. Thank you all. Live long and prosper.
Thank you very much, Audrey. We too are looking forward to the establishment of the new ministry. Now, our advisor, Director General Dr. Jang-Hwa from the IDB is also here today. He will tell us on what IDB has been working on for the transformation of industries with AI in Taiwan. Dr. Liu, please.
Okay. Digital Minister Audrey Tang and Dr. Lee Yuh-Jye and Jonathan Xie Shuilong from Boston and Mr. James P.A. and Mrs. Tabassi and Dr. Jeannette Yuan and the friends online. Good morning and good evening. I'm delighted to take part in this workshop on behalf of MOES IDB Industry Development Bureau. The global economy is facing immense pressure due to the pandemic inflation and other factors. Nevertheless, Taiwan is still diligently working on digital innovation and digital transformation, especially on the introduction of AI technology into respective industries. In response to the rapid development of AI and also to show our determination to develop and apply relevant technology, the Taiwanese government has been actively supporting our private sectors in implementing AI technology into their businesses. As industries in Taiwan gradually shift toward an AI environment, the trend has boosted their developments in several areas, including talent cultivation, technology development, environment building, and regulation adjustment. In the past few years, the MOES IDB worked with 33 industry public associations to help the industries conduct AI upgrades and transformations. So far, the collaborations have facilitated over 70 AI applications in the industries and continue to promote solutions and successful cases in more sectors. However, with the increase in AI applications, we also have to think about how to manage or monitor the risks brought forth by AI usage. So the EU and the United States American have gradually rolled out various policies and regulations since 2019 to ensure the trustworthiness and the fairness of AI technology. The US government, for example, announced the American AI Initiative in 2019 and the guidance for regulation of artificial intelligence applications in 2020. Both of them, these guidelines for trustworthy AI as one of their key points. Since we strive to become a trustworthy AI industry partner worldwide, Taiwan will actively seek collaborations with national level laboratories such as NIST in the United States American and the LME in France, and introduce relevant technical specifications and standards from the US and the EU to Taiwan's AI products so that the items comply with internationally accepted standards and requirements. We aim to increase national competitiveness and the awareness of our people by implementing secure, trustworthy, and ethical AI in civil society issues, such as public welfare and equality. However, we need the assistance of every one of you to realize this goal. As an important and trustworthy global partner, Taiwan will continue to invest in relevant collaborations. The development of AI technology and the AI transformation in industries are a crucial part in realizing Taiwan's 2013 goal of becoming an innovative, inclusive, and sustainable smart nation. And the trustworthy AI is a key factor to ensure that the risks of AI technology can be monitored and managed. I believe that your contributions here today will benefit the following actions and the development of this course. Last but not least, I wish this workshop great success and wish you all a fruitful morning. Thank you. Thank you very much.
Thank you, sir. Have a good day too. Last but not least, we have the Deputy Executive Secretary from the Office of Science and Technology Policy of the National Science and Technology Council, Dr. Yuh-Jye Lee, who is also our keynote session chair today, is here to share his visions on trustworthy AI with us. Dr. Lee, please. Hello, sir. Hello, sir. Your microphone is not on.
Good morning and good evening and good afternoon, everyone, and our special distinguished speakers. It's my great pleasure to participate in this trustworthy AI. It's a very important and serious issue for AI applications. I remember that maybe in 2016, Professor Fei Lee created a term called AI democracies. That means everyone can learn AI for free. There are a ton of papers on the web. Many open data sets are available. And also there are many free pre-trained AI models. And we can use the cloud computational resource. That means everyone can implement the AI applications. However, if we would like to use AI to the real world applications, I believe that we have to be aware of the potential risk behind the AI applications. For example, the sexual and race discriminations is not on purpose. It's just because of data bias. But when the AI engineer implement the algorithm, they did not aware of this problem in behind. As someone might use AI to hurt human rights on purpose. For example, the social credit, they try to monitor every activity in physical world, also in the web space. Last, when we would like to use the AI, we have to know how the AI systems operate. We have to able interpret the result of AI. The AI algorithm have to be transparencies, and that's the way we can trust the AI systems. Today, we are not discuss about the efficiency of AI algorithms. I think that's a big jump. We are talking about more serious issues, trustworthy AI. We have to know how to use AI very responsible to the end users. We have to know how to use the data without hurt people's privacies. It's great. I believe through today's workshop, we will understand the AI more, and we can use AI more suitably, and we can use AI to benefit the human right. I think I would like to stop here, and maybe I have to switch to the host, the keynote speech section.
Thank you, sir.
Thank you.
Thank you all very much. And now we would like to take this opportunity to invite all our esteemed guests to take a group photo together for this special occasion. Please turn your cameras on. Dr. Chang-Hwa Liu, Dr. Yuh-Jye Lee, Dr. Jonathan Xie from the Executive Director of Science and Technology Division from Taipei Economic and Cultural Office in Boston, Ms. Elham Tabassi, ITL Chief of Staff from NIST. And we have Professor Jeannette Wing, Executive Vice President for Research from Columbia University, and Mr. Ethan Tu, founder of Taiwan AI Labs. Ms. Karen Chang, Chair of FIDO Taiwan Regional Forum, and Dr. Shang-Wei Chou, Principal Engineer from Egis Technology. Dr. Jang-Hwa, Deputy General Director of ICL at ITRI, and Professor Jian Xu, Professor of Computer Science and Information Engineering from National Taiwan University, and Dr. Zheng Yaoling, Chief Executive of National Measurement Laboratory and General Director of CMS at ITRI. And last but not least, our co-chair, Dr. Wei Cheng Huang, Deputy General Director of ICL at ITRI. Well, looking good. We have our guests on. Thank you very much. Are we ready? Okay, thumbs up if you like. And on the count to 3, please say cheese. 1, 2, 3, cheese. Perfect. Thank you all very much. Hope you and all our audience enjoy today's event. Let's start. Now let's get into the exciting part. Allow me to introduce our keynote session chair, Dr. Yuh-Jye Lee, who apart from his government duty is also a renowned professor in cybersecurity and AI technology from National Yang-Ming Chiao Tung University. And just a reminder, if you have any questions for our speakers, please use the QA form to let us know. Thank you, and let's hand this session over to Dr. Lee. Dr. Lee, welcome.
Thank you. It's my great honor to introduce our keynote speakers, and it's very interesting experience. Actually, I knew these keynote speakers before. The first keynotes come from the NIST, Dr. Emma Tabassi, and I believe that we on the same workshop in April 21st. Hosted by the political magazines. And at that time, Elham talked about the AI standardization, international standardizations. And today, she will introduce the AI risk management. I think the NIST always set up very nice framework, either in the cybersecurity, also in AI risk assessment. So please, Elham Tabassi, welcome.
Thank you so very much for that very kind introduction, for a great series of talk, giving a great segue to my talk, and also being among this distinguished group of other panelists that I am looking forward to listening to their talk. You guys are giants, and I have learned a lot from you, all of you. Again, thanks for the opportunity to say a few things about the AI risk management framework. I'll start by saying a few words about NIST, who we are. NIST, as the federal laboratory within the US with a mission focused on driving US innovation, supporting economic security, NIST plays a central role in advancing critical emerging technologies, from AI to quantum information sciences, advanced communications, and smart manufacturing. Next slide, please. NIST has a long-standing reputation for cultivating trust in technology, We do that by participating in the development of the standards and advancing measurement science, standards and measurement science that makes technology more secure, usable, interoperable, robust, reliable, in other words, more trustworthy. And we all agree that this work is critical in AI space to ensure the public trust in this field. In this slide, what I'm trying to show you is the breadth of the NIST AI program. I will spend most of the talk about the foundational research to advance trustworthy responsible AI program, but as I said, NIST has a very broad portfolio of research. Our scientists across lab are using AI as a tool in advancing their research and scientific discovery in their own field of research, from bioengineering to quantum informations to modeling the behavior of the fire or why building collapsed. I mentioned that evaluations and benchmarks is our bread and butter. We are known for measuring an importance of the measurement and particularly on certainty quantifications. We participate in development of the standards both nationally and internationally, and we do that by contributing technical finding of our research to advance development of the standard that are scientifically valid and fit for purpose. We also contribute to discussions around policy for AI in the US, and just like all of you building AI program, we are advancing, we're the infrastructures and workforce for AI. Next slide, please. As I said, I'm going to focus my talk on the development of the AI standard and AI risk management, and also standard and evaluations. But just want to mention that we are also established a National AI Advisory Committee that's a presidential advisory committee, and a group of experts are working on a wide range of ideas on how to advance AI and US leadership and workforce and standardizations and international engagements. So what we're trying to do with the development of the AI risk management framework. Next slide, please. As we all know that the landscape of the policy and is evolving across the globe, what we are trying to do with this AI risk management framework is to get to the questions of what constitutes trust, right? We all want to advance trustworthy AI, minimize the risk of AI. What do we mean by trustworthy AI or responsible AI? What constitutes trust? So what you see here is the 4 functions that in the draft AI risk management framework, we're advancing on understanding AI risks. So through the map function, that's for understanding context, identifying risks, and understanding the impact and possibly the negative impact of some of the risk associated with AI systems. There are several things that I need to unpack, and I'll do that in the next slides, about what are AI risks, what's the definition of that, how do we, the trade-off among them, which I'm going to talk about those things in the next slide. Once we, if you can still stay on the previous slide, sorry, thank you. Once we know what it is that we measure, but we understand the risks, then we need to have, be able to measure them, because we are all this big fan of Lord Kelvin's quote that if you cannot improve it, if you cannot measure it, you cannot improve it. So through the measure functions, there are guidance and on how to identify, how to measure the magnitude of the identified risk. And then all of this information is going to be fed into the manage functions to help do the risk management based on the information about the risk, their impact, positive or negative. How to maximize benefit and minimize the risk, and all of that are being done through governance. We often say that everything starts with governance and ends with governance. The goal of the governance is really promoting a culture of risk management, along with the proper policies and procedures to ensure that risk and their potential impacts are identified, measured, and managed appropriately. Next slide, please. What are the meat of the document? So I start by talking about one of the things we want to do is understand what constitutes trust. There are all these very high-level aspirational goal of ethical, fair, trustworthy. What we are trying to do is translate them into characteristics that can be designed, developed, and get the AI system evaluated against them. What you see in this slide is what was proposed in the first draft of the AI RMF. And I think all of you look at them and they make familiar, and we heard many of them in the talks before my talk, that we want AI system to be accurate, to be functional, to be valid, to be reliable, to be robust to the different changes in the environment. Beyond that, we want also the AI systems to be explainable, interpretable, privacy preserved, safe, and harmful bias to be managed. And of course, under the guiding principles of fairness, accountability, and transparency. While we all of us agree on this type of characteristics for AI system to show to be trustworthy, one important exercise that we are undertaking is to bring the whole community on a shared understanding of what we mean by each of these components. So I'm going to go through, for example, the example of bias, but we have built some research program around several of these characteristics. Next slide, please. In a document that was published in March, we provide a sort of a taxonomy of bias, and what we basically showed in that document is that bias is more than the bias in data and algorithm, something that we know as computational bias, and the importance of the human bias and systemic bias in understanding the whole bias of the system, and also how bias manifests itself across the different stages or dimensions of the life cycle. Next slide, please. So the emphasis here, and similar to other characteristics that, if I get to talk about them, is that they open up the aperture to beyond just a technical measure and consider the context, consider the socio-technical context, and because all of the AI systems are socio-technical and impact human by the nature. Next slide, please. And I'm sort of again, in the continuing the theme of the socio-technical system approach, the document that I mentioned for the bias in AI that was published in March 2022, it talks about managing bias in the context and in the apply human-centered design to AI system and consider the broader set of perspectives. At the same time, follow the scientific integrity and scientific testing, right? You know, for example, in software engineering, all of the systems usually get through rigorous test and validation verification before they come out. Are we doing the same thing for the AI tools and AI system? Do they go through that type of rigorous test evaluations, verification, validations before they come out? The importance of setting up governance structures for the people who build and maintain AI systems. And the AI RMF talks a lot about the governance. And I say personally that if we can get one thing right with the AI RMF, should be instilling a culture of trying to understand and be proactive about risk and negative impact of AI systems to make sure that they are not an afterthought. We are not testing the AI systems for the bias or explainability or privacy risks after the system is built and deployed. But to get all of these discussions as from the get-go as part of the design, as part of the first and early stages of making decisions about building or deploying AI systems. And of course, understanding and considering limitations from an impact and value-based perspective. So making sure that we reach out to a very diverse group of people and diverse set of perspectives who can think about the impact of the system before the system is get into the operation and deployment. Next slide, please. We have done similar research, and we have started similar research for explainability and interpretability. In many literatures, explainable, interpretable, and transparent are being used as sort of synonym. So through the work that we had done, a couple of publications, we proposed 4 principles of explainable AI, that systems have to have explanation. Explanation must be meaningful to the people, to the person that the explanation is being presented to. So the explanation presented to, for example, the AI system is understanding the, medical imaging explanation presented to the technician versus the doctor would be at a different level. And that the explanation should be accurate and should be contained into the scope of the intended purpose of the model or system and what it was designed for. And follow that up with some publications that talks about the differences between explainability and interpretability. So we heard again that interpretation of the AI systems is really important, and there are already some laws on the book, for example, in the financial sector that if there should be explanations, for example, when the loan applications is denied. Next slide, please. Similar sections and similar discussions and similar research built around understanding resiliency and security of AI systems. They again start up with a document on terminology and taxonomy, and follow that up with building a sort of a platform for evaluations of the AI system that's right now on GitHub. Next slide, please. The privacy of AI systems, there is, of course, a very energetic area of research, and I think maybe it was December 2020, maybe a paper from Google showed that the AI models can basically memorize the whole training data. So if it's patient data, that's a really serious, can be a really serious privacy risk. So to understand better and engage the community and motivate the community to advance the research in privacy enhancing technology, US and UK are launching, or they had launched, what you see here is the announcement of the launch of the prize challenge in privacy enhancing technology. I think the call for abstracts is open until early September. Next slide, please. I think you need to go forward. You went backward. Next slide, please. The 2 other things that I want to briefly talk about is evaluations and standards. Evaluation, as I said, is our bread and butter, and we are a big fan of the Lord Kelvin's code that if you cannot measure it, you cannot improve it. And benchmarks serves many purposes beyond understanding the failure modes, why the technology fails, the limits and capability. Understanding the limits and capability, it can also bring interoperability on the way testing are being done. Standard is also really important. Standards is our middle name, but we are not standard development organizations. In the US, there are laws and policies in place that standard development is bottom up, it's industry-led, and federal government job is to support and provide technical contributions and support the industry in standard development. There are several activities going on in the standardization, international standardization of AI. And I personally think that's extremely important because good standards provide sort of a rule of the road that allows for innovation to happen and bring interoperability and spur innovation. My last slide is just tell you about the broad range of the work that we do to be able to do the risk management framework. We need to do foundational research on understanding the risk, understanding bias, explainability, privacy, security. But we also need to understand how these things manifest themselves in their particular context, a particular use case. So how bias is understood, measured, or the level of the magnitude and importance of that for face recognition is different than, for example, autonomous vehicle, for example. And then the interactions among those technical characteristics that I mentioned manifest themselves differently for the different applications. And then move on to taking all of this knowledge to the standard development of the standard and best practices to provide some sort of a as I said, the rules of the road for interoperability and advancing the field and spurring innovation and get those standards, all those knowledge into the adoption to actually all of us can benefit the promises of this technology, of this discipline in a way that's responsible and improve all of our lives. With that, I thank you, and I do have some links for AI risk management if you want to contact us. The two things very quickly: the development of the AI risk management is an open, transparent, collaborative process. We have, as you know, we have done several workshops, several rounds of draft for public comment. The next draft is coming up in a few weeks for public comment. Our workshops are open for participation by everybody. Our last workshop is going to be in October. We'd love to hear from you and your inputs on the AI risk management framework. And the last thing I want to say is the AI risk management framework is a voluntary tool. NIST is a non-regulatory agency, and while we work with policymakers, we do not make regulations. So the whole document will stay as a voluntary tool for the use by community. Thank you.
Thank you so much. We have a question from the ITRI Judy. I guess I have to tell her question. Okay, her question is, do you think which technologies for AI trustworthy in Taiwan should do first to cooperate or contribute to the worldwide AI societies? Or which domain Taiwan have advantage could contribute to the worldwide?
Yeah, that's a very good question, and I think I would try to answer it sort of globally, and then I'm sure that you're all familiar with GPay, and they try to kind of advance the different applications, or they talk about AI for good and applications that can advance, that can improve the quality of life right now. So, you know, coming and out or trying to come out of a pandemic, certainly health applications and trying to understand and predict health issues such as pandemic is really important. Energy issue because of the climate and all of these things that we are seeing is another really important one. Transportations, agriculture, all of them are really extremely important for improving the quality of the globe. So.
Okay, thank you so much. Actually, we are looking for the framework provided by the NIST, and thank you for your talk. And since we have 1 more minute, we don't. Okay, we have another question. for the RMF of AI, how to address the cultural difference between regions?
Yeah, these are two really good questions in the chat. And the second question is also about, well, everything that you said is very general. How about, but AI is about context. How about that? I failed to mention that AI RMF is also talking about profiles. So when the second draft comes out for public comment, there's also going to be a call for contribution for profiles, which are instantiations of AI RMF for particular use case or domain. So that's for the applications. The cultural differences is also a very good question. That's why I would intentionally stay away from words such as ethical or fair, because this will have a very dependence on the cultural culture and region and all that, and you know, even the level of safety, the level of privacy, all of these things. So bottom line, what I'm trying to say is that AI RMF, when it talks about the different risks, it talks about how to measure the risk, does not prescribe risk tolerances. That is something that we believe there is no one size fits all, and it has to be up to the designer, owner, the deployer, developer of the applications to, based on their appetite for risk, based on their values, understand what's the right one. So we go all the way to provide all of the building blocks to do a risk management without really prescribing the level of risk there.
Thank you. So that's thanks Elham again, and we will move on to the next keynote speaker, Professor Jeannette Yuan. And actually, I knew Professor Jeannette Yuan in 2006. I believe that it might be her first time to visit Taiwan. At that time, Professor Yuan used the model checking formal method for cybersecurity, that kind of things. But after that, I noticed that she has a very famous article, Computational Thinking. Right now, this article has become my machine learning lecture reading assignment. I only have two reading assignment in my machine learning lecture. One is computational thinking. One is written by Professor Domingos from University of Washington, a few useful things about machine learning. I follow Jeannette Yuan very well, and I still remember there is a talk in Vienna. She used the machine learning in her talk. I also always use this video to promote machine learning. So let's welcome Professor Jeannette Yuan. Today she will talk about the trustworthy AI. Let's welcome Jeannette.
Thank you very much. I am honored to be here and to talk to this audience about perhaps my favorite topic right now, trustworthy AI. I should mention that I had met Elham in a workshop that was sponsored by NIST on this topic of trustworthy AI, and when I saw she was on the program, I said, well, I want to participate and hear about what she has to say. So I'm going to talk about trustworthy AI from 2 points of view. Next slide, please. Obviously, I'll put into context something everyone already knows, that AI has achieved or exceeded human performance in many application areas. We can see objects in the road. We can talk to home devices in the living room. And of course, the most famous example is a machine beating the best Go player in the world. Next slide, please. We also believe that AI can benefit humanity and society in many of the application areas that have been mentioned already in terms of transportation, agriculture, medical care, and so on, are all ways in which we want to benefit society. We're going to have self-driving cars. We already know that in some cases, a machine can outperform the diagnoses of, say, X-rays over humans. The whole idea of using AI in the criminal justice system is to be fair to all the defendants and not to be subject to the biases of human judgment. And we're even seeing the prevalent use of AI in just hiring. Many jobs are out there, and many applicants are applying to those jobs, and it's a lot for a single human being or a few human beings to process all the applications. So right now we're seeing the use of AI in the hiring process. Next slide, please. However, we also know that these AI systems are brittle and potentially unfair. So you can add duct tape to a stop sign and the classifier will say it's not a stop sign. You can add noise to an image and the classifier will say what is a benign tumor is actually malignant. And we also have many press articles that have shown that the AI systems that are used in the criminal justice system can be biased. And finally, we also know that tech companies that try to use AI for, say, the hiring process had to scrap these systems because of bias. Next slide, please. So the question I ask this audience and the question I ask the entire community is, how can we deliver on the promise of the benefits of AI, but address these scenarios that have life-critical consequences for people and society? In short, how can we achieve trustworthy AI? Next slide, please. So I want to put this into context. I'm coming from the world of trustworthy computing. Trustworthy computing is a term that has been used since the early 2000s with a lot of interest in trustworthy computing coming from the security community, reliability community, dependability community, and so on. And a lot of interest, not just in academia, but in government. So when I was at the National Science Foundation, we had programs on trustworthy computing or trusted computing, and also in industry. I spent a sabbatical at Microsoft in 2002, primarily to find out what Bill Gates meant by trustworthy computing in the memo that he published in 2001. So trustworthy computing has come to mean the following in terms of trustworthiness. Reliability, does it do the right thing? Safety, does it do no harm? Security, how vulnerable is it to attack? Privacy, does it protect a person's identity and data? Availability, is the system up when I need to access it? Usability, can a human use it easily? Where a computing system is made up of hardware, software, and of course the people who use it. Next slide, please. It's from this context of trustworthy computing that the notion of trustworthy AI ups the ante. We have to add new kinds of trustworthiness properties to the meaning of trustworthy for trustworthy AI. So besides the trustworthiness properties from trustworthy computing, we add these properties that Elham has already mentioned. First, there's accuracy, robustness, fairness, accountability, transparency, interpretability, or explainability. And I think there are ethical issues, whether they're culturally different or not. And there may be properties yet to be identified. Next slide, please. So what do I mean by trustworthiness, these properties? For accuracy, this is the gold standard in machine learning today. And maybe many of the things we measure are torqued towards this over in an imbalanced way. So accuracy, how well does the AI system do on new, unseen data compared to data on which it was trained and tested? Robustness, how sensitive is the outcome to a change in the input? Fairness, are the outcomes unbiased? Accountability, who or what is responsible for the outcome? Transparency, is it clear to an external observer how the system's outcome was produced? Interpretability or explainability, can the system's outcome be justified with an explanation that a human can understand and or that is meaningful to the end user? And there are ethical issues like, was the data collected in an ethical manner? Will the outcome be used in an ethical manner? Next slide, please. So my question, how can we achieve trustworthy AI, now brings me to the second part of my talk, which is about using formal methods. The first part of my talk was basically to say trustworthy AI ups the ante on trustworthy computing. The second part of my talk ups the ante on formal methods to say, oh, formal methods community, you've been paying a lot of attention to traditional computing systems, but now you have to pay attention to these AI systems. What tools do we bring to the table to help AI developers and AI users trust the systems that they're developing or using? So thank you. So I want to start from the traditional framing of formal verification or formal methods. We traditionally frame it in terms of E, double turnstile P. So you read this as E, M satisfies P. Let's just take M. M is the model, is a program, a piece of code. It could also be something more abstract than a piece of code. It could be a protocol, for instance, as described by a finite state machine, or it could be an abstract model of a concurrent or distributed system. There are many such abstract languages and techniques. The double turnstile is read as satisfies, and this is where logic, mathematical logic, comes to play. And the tools that have the formal methods community has built over the years have embodied different kinds of formal logics, and they allow us to do different kinds of proofs. These tools are now off the shelf. They're model checkers, theorem provers, satisfiability modulo theories, or SMT solvers. And in the past decade or so, these tools have really come together to make the use of formal methods industrial strength. And P stands for the property that we care to prove of the program M, using the logic represented by the double turnstile. So P is usually described in some kind of discrete mathematical logic, a Boolean logic, and over many decades of research in the 80s, we've come to classify properties for computing systems in terms of safety and liveness properties. We don't have that similar characterization for AI systems, by the way. That's a new challenge. And sometimes we include the explicit specification of the system environment. That's E. So together we have the combination of E, M satisfies P, and that is a logical formula. It's a mathematical object, and we use the mathematical logic to decide whether this statement is true. Does E, M satisfy P? And of course, more often than not, it does not. And what happens is we find a counterexample that tells us why the program doesn't satisfy the desired property. So from traditional formal verification, go back, next slide. Okay, stay there, please. We up the ante. We now want to verify AI systems. And now we reinterpret M to be a machine learn model. So this is a model that we might produce using a machine learning algorithm trained on some data set. And the satisfies double turnstile has to be reinterpreted in terms of likely probabilistic logics, or at least new kinds of ways of determining satisfaction. P itself as a property may very well be stated in terms of probabilities or stochastic processes. So P no longer is written as a Boolean formula. It might be much more complicated. And finally, analogy to E is what I call D, the model of data. D is like the environment or the assumptions that we make about the environment or the assumptions we make about the data that we're using to train the model and test the model and then deploy the model in real life. So you might think that this is overly ambitious, and I think it is actually quite ambitious. I don't know if it's impossible, but it's definitely ambitious to recast the formal methods framing EM satisfies P for AI systems. A glimmer of hope is that M, while M is a very complicated model, think of a deep neural network, in the end, it's still a program. It's a piece of code. So it gives me some hope that there may be techniques that we can invent that can analyze these very complicated pieces of code, much like we can analyze very complicated pieces of code that human beings write. Next slide, please. So this is the characterization of what I imagine the verification of an AI system to be. Take the model of, or the AI system that has a machine learned model, or the machine learned model itself. Take the trustworthy property that you care about, whether it's robustness or fairness or transparency, that obviously needs to be able to be expressed mathematically. That already is a challenge. Take the potentially new logical system, maybe a probabilistic logical system, and try to determine whether M satisfies P in the context of some assumptions about the data used to train, test, and perhaps deploy M. Next slide, please. So I wanted to characterize what I believe are the two main differences between the traditional framing of verifying a program with respect to a desired property for trustworthy computing and trustworthy AI. The first is the inherent need for probabilistic reasoning, and I will get into this in more detail later. The second is the very important role of D, data. Especially the two middle bullets in my list here, specifying unseen data and what do we quantify over. And I'm going to go into more detail about these in the subsequent slides. Next slide, please. So why do I argue that we need probabilistic reasoning? M, this machine learned model, let's just think of it as a DNN, is semantically and structurally different from a typical computer program. It's inherently probabilistic. If you think about a DNN where you have probabilities on the edges, it's just, and probabilities that are output, it's just, it's a probabilistic animal. Internally, the model itself operates over probabilities and outputs results with assigned probabilities, for instance, a DNN. Structurally, it's very different from what a human being would write. M is machine generated and unlikely to be human readable. It's another kind of intermediate code, if you will, which also gives me hope because the programming language community is very good at analyzing, generating different kinds of intermediate code and analyzing different kinds of intermediate code for multiple purposes. So the M is inherently probabilistic. P, the property P, may be formulated over continuous, not just discrete domains, and or using expressions from probability and statistics. For example, robustness properties for deep neural networks are characterized as predicates over continuous variables. Fairness properties, perhaps the best known being fairness properties are characterized in terms of expectations with respect to a loss function over reals. And then finally, differential privacy, which is probably the best known formalization of some privacy property, is defined in terms of a difference in probabilities with respect to a small real value. So P is not a typical Boolean formula as we know and love from the traditional formal verification of computing systems. And finally, the logical frameworks we might use to prove that M satisfies P will likely need to draw on probabilistic logics and hybrid logics. The good news is that we have probabilistic logics and hybrid logics. The formal methods community has not been sitting on their hands, but in fact has been quite productive in the past couple of decades in coming up with probabilistic logics and hybrid logics, primarily to reason about cyber-physical systems and robots. But what we need are new scalable and/or new verification techniques that work over reals, nonlinear functions like sigmoid and step functions, probability distribution, stochastic processes, and so on. So this is really a call to the formal methods community saying we need new techniques to do this kind of verification, given the entities that we're trying to manipulate are themselves non-traditional. Next slide, please. And now the second important difference is the role of data. And I want to first introduce the notion of to distinguish between available data, data that's used at hand, data at hand that's used for testing and training the machine learning model, and unseen data. Unseen data is the data over which M needs or is expected to operate without having seen it before. The whole idea of using machine learning is to produce a model so that we can use it on data we've never seen before. That's the phenomenon, and that's the incredible power of machine learning. Next slide, please. So of course, in collecting and partitioning data, we can ask questions. We have opportunities to ask questions like, how should we partition a given data set into a training set and test set? And if we can partition these things, can we make guarantees of the partition with respect to a particular desired property in building a model M? There's even the question of how much data suffices to build a model M for a given property P. Does adding more data to train or test M make it more robust or fairer, or does it not have an effect at all? And what new kinds of data need to be collected if a desired property does not hold? And I will return to this point later. Next slide, please. Probably one of the biggest technical challenges in trying to apply formal methods to verify AI systems is specifying D, where D stands for the unseen data. Because you haven't seen it, you don't know what it looks like, and you hope it looks like something you've seen before, but you don't know. So how do we specify the data and/or characterize properties of the data? We could specify D as a stochastic process or a data distribution via its parameters. Like if it's a normal distribution, then it's very easy to define the distribution in terms of the mean and variance. We could also use something even more sophisticated, probabilistic programming languages, for example, STAN, which are very good for specifying statistical models. And the beauty of using a probabilistic programming language is that it's like a meta description language. So you can actually define many models at once with one program. But what of large real-world data sets that do not fit common statistical models like normal distribution, or which have thousands of parameters, which perhaps would even be too much for a STAN programmer? And the last point, this real-world data sets, that's reality. This is what we are actually working with. And if you look at the big tech companies, this is what they're so successful at collecting and using and training the models that they put out for general use and for their internal use. There's one technical dilemma that I thought I would share with you because it seems like a bit of a conundrum. And that is, there's a bit of circular reasoning perhaps going on here. To specify unseen data, we need to make certain assumptions about the unseen data. Would these assumptions not then be the very same as those we would make to build the model M in the first place? In other words, how can we trust the specification of D? So we move the trust around. This is not uncommon in trustworthy computing or in security in general, and that's moving the trust around. But this is an example of where we've just moved the trust around. So there's some approaches that I propose here. One is to use statistical tools, completely different techniques to verify, if you will, the specification of D. Or you can assume the initial specification is small and simple enough that you can check it manually. And then finally, there's an approach that is used very commonly in traditional formal methods called counterexample guided abstraction refinement. And so we can be inspired by that approach where we use this small specification to bootstrap an iterative refinement process and get a larger specification of D. Next slide, please. There's another technical question that is raised by diving into what it means to verify an AI system in this framework. And it has to do with what do we quantify over. In traditional formal methods, we strive to prove for all x p of x. For all values of the integer variable x, we prove p of x. And so it doesn't matter whatever integer value might feed the program, we know it's going to be true. And even if the computer can't represent all the integer values, we've overproven the property. Similarly, for all possible behaviors of a concurrent distributed system, we'll prove p of x. But for AI systems, we do not expect the model to work for all input data for all data sets D. So we have a bit of a question of what are we quantifying over and how can we make progress over this. Next slide, please. And let me just give you two examples of why perhaps looking at the property might raise interesting and new questions about what to quantify over. So for instance, for robustness in the adversarial machine learning setting, we might want to show that M is robust to all norm-bounded perturbations D. More interestingly, however, we might want to show that M is robust to all semantic or structural perturbations for the task at hand. For instance, in computer vision. We know it's very easy to fool a computer vision system, a classifier, by just adding noise to an image, and a classifier might say that a panda is actually a gibbon. But a structural difference would be if you're using a computer vision system in your self-driving car, you want the computer vision system to not care whether the car in front of you has a dent in the bumper. It's still a car, and you don't want the car, the self-driving car, to do anything different just because there's a dent in the bumper. So for that task at hand, you want to ignore the dent. On the other hand, if the task is, to take the car to a repair shop and look for the things that the car needs to be fixed, and then you want to see that dent, and you want to tell the repair person, fix this dent. Next slide, please. Along the lines of the same question of what to quantify over, in terms of fairness, we might want to show that the machine learning model is fair on a given data set and all unseen data sets that are somehow similar to it. Right now, what we do is we show a machine learning model is fair with respect to a given data set, but we don't want to show that it's fair to just one data set. We want to know that it's going to be fair for future data sets or future distributions of data, for instance, in the hiring process or criminal court system. So when my colleagues and I at Columbia showed a couple years ago in a NeurIPS paper that it's very easy to show that, quote, the fairest classifier you can build can be brittle. So what we built in that NeurIPS paper was a game theoretic algorithm, an online dynamic algorithm that basically makes fair classifiers robust. So you get fairness and robustness at the same time. But of course, you give up a little accuracy, et cetera, et cetera. So this is all a very ongoing research, of course. Next slide, please. So this is the near the end. The verification task is simply, pound away at some logical, using some logical framework to show that DM satisfies P. I won't go into this. Next slide, please. I wanted to say that I came at this framing with the traditional sense of verifying a machine learned model with respect to a property in a somewhat post hoc method. But you can also use a formal methods framing to think about correct by construction, where you take the specification and you refine the specification, and as you're refining this specification, you're building a correct or trustworthy AI model along the way. And then the last point I wanted to make are the statistical methods that one can use in model evaluation and model checking. And the main point about that, this slide, is to say that the statistics community has a lot to offer in terms of methods and tools, especially for reasoning about bias. And we should look to the methods from statistics in helping us understand what we can borrow in terms of verifying AI systems. Next slide, please. And that's it. So this is the framing I'd like you to remember. DM satisfies P. Thank you very much.
Thank you so much. And indeed, we have many questions from our audience, but we run out of time. Let me just give you two questions. One is for myself. Actually, I have a headache when you talk about how to specify the unseen data. Because when I teach machine learning, I always say why we can learn from data, because we assume the data come from fixed but unknown probability distribution. But obviously, in your presentation, you try to break this assumption, right? So how to?
I mean, the reason I think we need to break that. I think for controlled, when you're teaching, you can make those assumptions and so that you can make progress. But in the real world, and this is really something that we have seen in terms of the big tech companies building massive machine learned models based on all the data they can collect, more data they can collect than any of us in academia. It's not like they fit it to a normal distribution and say, here's the mean and here's the variance. They just have the data. Now, that's not to say maybe they're being lazy and not trying to figure out what is the distribution. Yeah. But in their world, they don't have to do that. They have the data, they have the compute power, and so they can just grind it out. And that's what they do. They do a lot of, using their cloud to grind out these machine learned models based on massive amounts of data. That's state of the art right now, whether we like it or not. And one of the reasons I think it's important for academia to continue pounding away, especially in trustworthy AI, is that there are going to be some things in advancing AI and machine learning that industry is not going to do. It doesn't have the time, it doesn't have the incentive, and it may not even care about the science. They care more about the technology and what the technology can do for a particular business. So, I think the academic community's responsibility to care about the science.
Yes, sure.
And so that's our role. That's what we can do. Because after a while, one does think, well, maybe throwing massive amounts of data and massive amounts of compute power, all of that will reach a limit. And maybe not. I don't know how if it will, and maybe not anytime soon. But when they do hit that wall, hopefully academia will have been plugging away at other approaches and have different ways to tackle the next big hurdle.
When you promote computational thinking, the target audience is not only for the computer scientist. You would like to push the computational thinking for K-12, right? But now the trustworthy AI seems more complicated. do you have any plan for promote the trustworthy AI use formal methods?
Well, I think there are two questions there. One is promoting trustworthy AI, and one is promoting formal methods. For promoting formal methods, I've been doing my entire professional career. My PhD thesis was on formal methods, and I have not given up on formal methods. What I have seen is the miraculous success of the use of formal methods in industry, something I would not have predicted in the 80s, but something that I definitely saw at Microsoft when I was at Microsoft, and I see it at Amazon right now, and they're using it in you know, for verifying very you know, core parts, core components of complicated systems that need to be, you know, basically extremely reliable and secure. So it's worth putting the effort into verifying those components, and that's where formal methods are typically used in industry. So in terms of formal methods, now, but that's not to say that, you know, even all our undergraduates who study computer science, many of the undergraduates never heard of the word verification, right? So we still have a long way to go in terms of just educating undergraduates, let alone K through 12 students on formal methods. What we can teach the K through 12 students is mathematical logic.
Yes, sure.
Because that's the foundations of formal methods. And once they learn mathematical logic, then they can go on and apply that learning, the understanding of mathematical logic, to do verification. Now, for trustworthy AI, this is so advanced an idea, you know, to put together formal methods, AI, and trustworthiness all in one, you know, triangle. That's really, for, you know, we're talking about graduate student PhD theses. That's where we are right now. We're not talking about, you know, teaching K through 12 students. We can teach them the concepts, but I don't think we're ready to teach them. You know, we can surely explain to them why an AI system might be biased. They can understand that. We can certainly explain why a self-driving car's vision system had better be robust.
I think awareness is very important.
But you know, so I do believe if you take what your question is about computational thinking for K through 12 students, I strongly believe that there are a lot of concepts that we teach in computer science or AI machine learning that can be understood by K through 12 students. It's not even dumbing them down. They're just explaining them in terms of the experiences that a child has.
Yeah.
You know, every child who has been in a car has been in a situation where the driver brakes hard because there's a little boy running across the car.
Yeah.
And, now imagine if there was no driver and the car had to see that little boy running across the street on its own and brake. So you can explain that to a child. They'll understand that.
Yeah, I think so. That's great. Because there's many questions, but we don't have enough time.
Yes, yeah.
I will email you because I'm so excited to see you after 16 years.
Okay. All right.
So
bye-bye,
when is
everyone.
your next time visit Taiwan? When is your next time visit Taiwan?
Oh,
Next
I don't
year?
know.
Let's plan for it, okay? Okay, thank you.
Okay, bye-bye. Good night,
Bye-bye.
everyone.
Thank you. So I'm sorry I run out of time, but we still have a very excellent, distinguished keynote speaker. I would like to introduce the Ethan Tu, and he is the leader of AI Lab. And AI Lab actually is the Asia first opening AI research organizations. And Ethan actually is quite famous when he was an undergraduate student. And today he will talk about trustworthy federated learning. Ethan, I turn the microphone to you.
Thank you, everyone. My name is Ethan Tu. I'm the founder of Taiwan AI Lab, and it's my great honor to represent Trustworthy Federated Learning to distinguished guests. So next page. So Taiwan AI Lab was founded in 2017. We were the very first open AI research institute, which means our research is open source, open algorithm. And the reason we want to establish this institute because in 2016, I worked for Microsoft, and the Dr. Win talked about the Microsoft. We actually deliver democratized AI solution for the entire world. And we believe that artificial intelligence will become a superpower in the future and not help people to make decisions. But after I come back to Taiwan in 2006, I talked to Audrey Tang, and we think there's one aspect we think it is very important is how we can make artificial intelligence to be transparent and to be able to explain for people, and that will become our main task. So we are the very first open AI research institutes focused on the human-centered open artificial intelligence technology. Next. And as the distinguished guys already talked about, there are a lot of issues when we train the AI algorithm. First of all, the environment can be biased. If the personnel trained using their practice is with discrimination, then the data will also discriminate. And if your sampling data is discriminate, or you haven't seen all the different data, maybe your data is biased as well. And if you didn't validate your AI algorithm in different unseen data, maybe the result can be biased as well. So there are a lot of issues when we talk about the artificial intelligence. And a lot of people in the past only talk about the precision and recall, but the precision and recall is only the precision recall for for the fixed data set, and that is actually not represent for at a lot of places. For example, for the precision health, you will train the data using the UK Biobank. Probably the AI model cannot be applied in Taiwan because we are Asian people. We call it the population bias. If you train a natural language processing model using the Chinese language, maybe it's not suitable for Taiwan because we are a democracy country. Our freedom of the speech is different from the other place who speak Mandarin. Next page. So in Taiwan, we are thinking about if we want to build up the infrastructure that preserve humans' privacy and the security, how can we achieve the response of AI? So back in 2017, when we talk about the response of AI, we discussed with Taiwan Clinical Trial Consortium. So together we want to achieve explainable, traceable, verifiable, and adaptable AI solution that we work with our local expertise who focus on preserving the human privacy and human rights. Continue. Next page. Hello. And also, if you look into the federated learning approach, that is the reason we are working. We working on the federated learning solution for healthcare, and in 2017, and after these 2 to 3 years, you can see a lot of federated learning solution is already applied in the whole world. Continue. Next page. The reason we adopt the federated learning solution in 2017, and we built out the very first open source federated learning architecture for the Taiwan's hospital and the individual to work on the base AI algorithms through a security in design, privacy in design approach. In this way, we want to when we design the AI algorithm, when we train the AI algorithm, when we collect the data, we can follow one standard protocol and one standard procedure to to make sure all the AI algorithm is without bias and all the security privacy is verified through this process. Continue. Next. So Taiwan was also the very first country initiate the Taiwan Federated Learning Alliance back in 2020. And the reason we started the Federated Learning Alliance was trying to achieve so if you remember in the past, when we talk about the best AI algorithm, we usually talk about how we can collect the most data. But in Taiwan, we did not talk about how we can collect most data. We talk about how we can train a trustworthy AI algorithm with a trustworthy fundamental learning approach. Next. So with this architecture, for example, we can connect to Taiwan residents' data in their personal device. And we can also connect to medical centers device, medical centers data centers. In Taiwan, we have the 80 plus medical centers, and with all the medical data, we already electrolyzed data. We can using a federated learning approach to train an AI model together. And with the same architecture, we can also have our federated learning solution in Taiwan National Database. For example, National Taiwan Insurance Agency database and Taiwan Biobank database. And all together, we can, with one protocol, train the best precision health solution without pulling all the data together, and we respect all the ownership of the data. Continue, next page. And with this solution, so we help the hospitals in Taiwan to do the AI hospital transformation in order to transfer the healthcare solution with AI assist solutions. Continue. And this federated learning protocol, we already deployed in 75% of the medical centers in Taiwan. And we reach 100% of the medium medical centers, hospitals in Taiwan. And now we have about 120 medical federated learning solution and the project running on top of this federated learning architecture. Continue. And you can see like a National Tang University Hospital and the Taipei Veteran General Hospital, the head of Taipei Veteran General Hospital also advocate this federated learning solution. So this federated learning solution we use in healthcare, for example. First of all, it work with one hospital and with one expert team in one hospital. After we train a reasonable AI solution, then we will deploy to multiple data centers to train with more data, with more experts in different hospitals. And after we have reached a reasonable AI model that is suitable across different hospitals, then we will again validate by more hospital in more environment. Then in the end, we will use the result of the federated validation for the TFDA approval in Taiwan. Continue. So by this way, we can train the AI algorithm in multiple hospitals in different environment. So then the next step, how we can do the validation. Like Dr. Wing already mentioned, how the AI model deal with the unseen data. So in the federated validation, we partnership with the Taiwan Clinical Trial Consortium. That is the biggest country level PI pool in Taiwan. Next page. So it contains 21 medical centers, 41 hospitals, and 7 academic institutions. And with this federated Taiwan Clinical Trial Consortium federated validation system deployed, the AI solution we trained by the federated learning can be validated by more hospitals, more medical centers in the federated validation approach. Continue. So through the pandemic since 2020, because in Taiwan, we have the Federated Learning Alliance for healthcare. We successfully built the resilience for the solution to against COVID-19. For example, we deploy the federated analysis approach back in April 2020. We call this Taiwan Social Distancing App. Without collecting all citizens' data, we use the decentralized approach to track the transmission of the virus by storing each individual storing their own contact history. Next page. And also together, because we respect the ownership of the data, so we can at the very beginning of 2020, because in Taiwan we have very few confirmed cases, we have very few COVID-19 chest X-ray. But with this federated learning approach deployed, we can have multiple data medical centers works with AI labs, starting from National Taiwan University to train the COVID-19 chest X-ray classifier. And with this chest X-ray classifier, we successfully deployed in National Health Insurance Agency from January to March 2020. We can detect 27 out of 109 cases that are or COVID cases that is earlier than the PCR result. Continue. And we also deploy the open source solution for the drug selection at the rate in February 4th, 2020. So with this open source solution, all the pharmaceutical company and all the medical doctors, they can leverage the same open source code to deploy in their in-house research center to test the drug, see if it is suitable for the COVID-19 treatment. And we also leverage the natural language processing approach to connect the discovery that is discovered in PubMed knowledge graph. So the doctor can select the drug treatment based on the federated drug discovery program. Continue. And we also deployed a speech recognition and language understanding mechanism for the hospital in different scenarios if they want to train their own AI model for speech recognition and language understanding. Continue. So altogether, we deploy this solution in the open source. Everyone, in other words, they can come to our website, codevirus.cc to see the result. And we also promote the federated learning architecture back to NIH. My previous I worked in NIH in 2003 to 2006. So we also go back to NIH to promote this idea. Continue next. And we were also invited by GPAI back in 2020, and we promote the federated learning in the responsible AI and data governance sessions. So federated learning, I think right now become a common language for the world. We can work together. Continue next page. So this is the whole picture. We starting from one idea. If you have any AI solution idea, you can start with Taiwan Federated Learning Alliance. And if your solution is for healthcare, then we can have Taiwan Clinical Trial Consortium to validate your result. Then if the result is good, then we can go to a software as a medical device evaluation under TFDA. And once this evaluation is good, then you can get the TFDA approval. So this is a critical path for the software as a medical device in Taiwan. And it is a top-down guidance, Taiwan AI Lab supported. So this is next. So this is the speech I have today, and I hope everyone around the world, if you are interested in the open source, open algorithm approach for the federated learning research, welcome to work with us. Thank you.
Thank you, Ethan. I think a shared model without sharing data is a very good idea. And due to the time limitation, I only provide one question from our audience. The federated learning is distributed system. For the issue of trustworthy AI, how to evaluate the fairness of AI model from different clinic data source?
Yeah, so before we have a federated validation approach, it is always a harder decision for TFDA and CDE, for example, to evaluate AI algorithm. It claims already solved the toughest the medical problem. But now we have a federated validation. So before we approve any AI solution, the federated validation, we will have different data set, different PI. Actually, they are from different hospital that represent different scenario. So like the doctor we mentioned about the environment, how we can make sure this AI model works also works in different environment that never scenes. So the federated validation, we work together with Taiwan Clinical Trial Consortium, actually set up a very good platform for the solution that may be trained outside Taiwan. When they come to Taiwan, they can validate through our federated validation approach to make sure the algorithm has no bias. Yeah.
Okay, thank you. So thank you for our three speakers. Excellent talk. And I'm not very good in time control. So we run out of time, but I think we still can take a short break. Let me finish my section and who will take over the next part.
Thank you.
Thank you. Thank you, Ethan.
Okay, thank you, our session chair and our speakers. We will now take a break for 5 minutes. Please be back at 10:46 for the future session. Thank you. Welcome back to the second half of the workshop. Let us invite our session chair, Ms. Karen Chang, Chair of FIDO Taiwan Regional Forum, to introduce our featured speakers. Just a reminder again, if you have any questions for our speakers, please use the QA form to let us know. Thank you. And Ms. Chang, the floor is all yours.
Hello, good morning, good afternoon, good evening, everyone. I'm Karen. On behalf of the event co-organizer, FIDO Alliance is more than happy to be here in this workshop with you all. And also, as the chair of FIDO Taiwan Engagement Forum, it's my honor to be here to be the session chair as well. Okay, moving on, we have Dr. Zhou's speech. Dr. Zhou received his PhD degrees in electronic engineering. He used to start up a company, and currently he serves in Egis Technology as the principal engineer, mainly focusing on mixed-mode SRAM-based CIM architecture development and self-learning algorithm development for noise suppression. In short, his specialties include sound experience of mixed-mode computing in memory circuits for deep learning and AI chips, CMOS and memory product and circuit design, and so on. Everyone, let's welcome Dr. Zhou of Egis Technology, feature Disentanglement for AI ethics. Welcome, Dr. Zhou.
Feature Disentanglement for AI ethics. I've divided my presentation into 3 parts. I'm going to start with the current situation. Then I will talk about trustworthy AI. And finally, what solutions we will expect. AI will improve humans' quality of life. It today brings more convenience and more useful function to humans. And with the advance in technology, you can no longer ignore AI's role in making those advances possible. In fact, AI has a role in all aspects of life, from the home to shopping to the workplace. Many homes are equipped with Amazon's Alexa, Google's Home Assistant, or Apple's HomePod. With a brief description of requirements, a device can help booking hotel, monitor home security, play music, and make shopping lists. Here, let's talk about an interesting application of voice conversion. This is a Lyrebird AI. It can generate a digital voice that sounds like users. The user only needs to read out 30 sentences according to the list and record the sound one by one. Lyrebird can use AI technology to learn users' voice, including the tone, in just 1 minute of recording. Then it can speak any text with user's voice. Let's do the demo.
Hi, everybody. This night I am happy to share with you a small announcement about a cool startup called Lyrebird. They launched today their website where you can create a digital copy of your voice. They only need you to record 1 minute of audio. This is just the beginning, and they are working hard to improve their results. They want to use this technology to change the life of everyone that lost their voice to a disease by helping them recover this part of their identities. Let's help them achieve this goal. You can help them testing their software and sharing this video with your friends.
This is the synthesized result. It's amazing. I have been talking about how powerful AI is. There are many cases saying that AI is really smart and seems to replace humans. Is AI smarter than humans? Have all the problems been solved? No, the AI does not always get it right. It is easy to be carried away and induced in the interaction with humans, leading to the wrong result. The following is the real case. Someone has developed a kind of glasses which look nothing special, just a pattern glasses. The man wears these glasses and the face recognition system will recognize him as the woman below. In fact, this does not only happen in face recognition. It may also happen in speech or text recognition. AI improves our life, but from another point of view, it is also a concern if people use AI for fraud or other illegal purpose. For more detail, you can reference Professor Lee's speech. So what do we need trustworthy AI? Because for many people, AI is an unexplainable black box. AI models and decisions rely heavily on designers' knowledge and experience. Is there human intervention in the decision? What did it do late? Will it cause privacy damage? Even we open the black box, we will find that the output is only a probability. How to train the model and what is the meaning of the trained kernel has always been a question. So how to modeling the trustworthy AI? It can be divided into 3 phases. First phase, data pre-processing to improve the privacy or use synthetic data to train models. Second phase, explainable AI modeling, understand decision-making process instead of blindly trusting AI. Third phase, continue model evaluation, investigating model behaviors through tracking model insight on deployment state, fairness, quality, and drift. Here, we talk about the Egis expected solution for trustworthy AI. Most importantly, avoid giving too much personal information to service company. So first one, using edge computing. The model can be trained or fine-tuned on edge device. We hope the raw data can be stored in on-device for privacy. Second one is using unsupervised learning. Don't require label data. The third is using feature disentanglement that decompose and visualize feature component. Taking voice conversion as an example, speech signal inherently carry both static information and linguistic information. The static part, such as speak, acoustic condition, is time independent and merely change during the whole utterance, while the linguistic part may change every several frames. As the figure, the speaker encoder is trained to encode the static information into the speaker representation. The content encoder is trained to encode only the linguistic information into the content representation. And then the task of the decoder is to synthesize the voice back by combining these 2 representations. The speaker encoder learns a meaningful speaker embedding even if we do not provide any speaker label. This technology has the capability to disentangle feature and content for utterances. We provide a simple application. Because voice conversion requires too many computing resources, we haven't implemented it yet at the edge. We apply it to the noise prediction and suppression application. Mechanical noise in life can cause hearing damage. What we want to induce today is active noise suppression. It can be applied to household appliances with loud noise, such as hair dryers and coffee machines. Just enter the salon room can reduce unpleasant noise. The working principle of this noise The question is not to block the noise, but using sound wave to against it, just like this figure. A key point is we only suppress the noise with specific frequency, but not all sound in the environment. Through the technology of feature disentanglement, the frequency spectrum features and amplitude are separated to model training and engineer side. When the product is delivered to user, the universal sound of specific frequency can be predicted successfully by noise amplitude without any supervision. This algorithm has been developed. The next goal we will implement on our edge computing IC. Thank you for your listen.
Thank you, Dr. Zhou. I think there's a question for you, and if you okay, please answer this question. The question is how to measure ethics in AI, and is there any reference implementation in ethical AI? That's the question, please.
In general, we require AI to be privacy, accountability, safety, explainable, and fairness. But as technology advances, there will always be new things, rule, and application. Past experience does not necessarily apply to current guidelines. For engineer and developer, integrating ethics into AI can be abstract, especially when the conditions keep changing. I think the better way is let AI learning continuously. Just like a parent raise children, we must constantly remind and teach children that need to be followed and carefully. Although it's not easy, ITRI is working on developing the solution that enable edge device to learn the actual behavior of the user while protecting privacy. Thank you.
Thank you, Dr. Zhou. And thank you and goodbye. And next we have Dr. Hua. And Dr. Hua is the Deputy General Director of Information and Communications Research Lab at ITRI. And prior to joining ITRI, Dr. Hua held the positions of professor at National Taiwan University of Science and Technology. He received the PhD degree from Purdue University of the United States. He incredibly won lots of awards in past years. Today, he would like to share with us the current status and future perspectives of AI development in Taiwan. Wow, looks a very important topic here and now. Everyone, let's welcome Dr. Hua. The floor is all yours, Dr. Hua, please.
Thanks, Karen, for the introduction, and good day, everyone. Today, I would like to share a little bit about the current status and future perspective of AI status in Taiwan. Next slide, please. So everyone knows that AI is important, and for Taiwan's government, we launched our Taiwan Action Plan from the year 2018. And the phase 1 spans 4 years from 2018 to 2021. And right now we are planning for the phase 2, which will launch probably from the early of next year. And for the phase 1, there are 5 major actions. First, we know that the AI talent is very important. So we do have a AI talent cultivation program to train and to recruit more AI talents. And the second, we do have the pilot project. For the pilot project, we identify the importance of a few important areas, and then the government funded these pilot projects to make sure that we do have a good foundation there. And the third one is International Innovation Hub. So we actually gather people from different domains and develop interdiscipline cross-domain innovation application. And the fourth one is testing field. And the last one is AI for industry innovation, including various fields like smart manufacturing, biomedical, green energy, and new agriculture. Next slide, please. So here I wanted to share a little bit for the achievement for AI for industry innovation. On the upper left, you see that it's an example for the AOI defect inspection. We know that Taiwan has a very good foundation for semiconductor manufacturing. In addition to this, we also have a very good ICT production. So we collected, working with various companies, we collected a lot of manufacturing data, and then we have developed a very robust defect inspection algorithm, which actually employed to various companies. So we help the local companies to have a better performance in the manufacturing stage. And also, you can also consider that with our developed and collected data, it's a global AI technology. We can actually export this technology into other countries. And on the center upper one, you can see another example for the portable Edge AI doctor. DI stands for doctor, also stands for diabetic retinopathy. And so for this, we actually design a low-cost portable device that can be used by a local clinic for an eye doctor to identify the eye issue for the early caused from the diabetic sickness. So in the past, you need a very expensive device to check your eye. But with this portable Edge device, we are helping the patients to be able to be examined more often and more frequently. On the upper right, you see the example for the self-driving bus. For the self-driving bus, they contains a lot of components like the sensing, control, and the hardware. So we will launch this POS, proof of service, by the end of this year in the Hsinchu city. In addition to the self-driving bus, we also have the cellular vehicle to everything communication protocol. And we have already transferred this technology into a few hospitals and fire stations. As you can imagine that for the ambulance or fire truck, when they went out from hospital or the fire station, the CV2X will build a connection from the self-driving vehicle to the traffic light. So we make sure when the ambulance is on the street, the traffic light will turn into green automatically to make sure the ambulance have a safer trip along the way. On the bottom part, there are a few other examples. On the lower right, you can see that it's a drone-based bridge inspection. So in the past, when we need to do the inspection for the bridge, it takes a lot of time to taking photos and perform the inspection. But through this technology, we can have this drone automatically taking the photos under the bridge and perform offline inspection. So it saves a lot of time. Next slide, please. Okay, so seeing a lot of achievement from the previous few slides, right now we are planning for AI action plan. It's phase 2, or we also call it plan 2.0. There are 5 major tasks, including that the first one is more talent and deeper skills. Although we did a very successful talent cultivation in the phase 1, but since it's very successful, so we need more talent. So again, we need to focus on this one. And the second one is advanced technologies and AI for small and medium-sized enterprises. And third one, we wanted to enhance our international influence. And the fourth one, we will build a better governance and infrastructure. And the last one is humanities and society. And next slide. And so for the following, we will focus on the 2 items. the advanced technology and AI for SMEs. So you can see the yellow letter here, FAST, fast. AI is developing very fast. So we need to improve ourselves very fast. So for the very fast components, on the left one side, it's the federated learning. Ethan has introduced all the details and the application in terms of healthcare application. So I don't spend too much time here. But again, here we do work with a lot of manufacturing companies. So they focus on healthcare part. We focus more on manufacturing part. But again, the core technology are similar. We can employ the technology into different fields. And second is AutoML. We know that for machine learning, there are a lot of steps, and some of them are like have a high barrier to enter. So including like feature engineering, model selection, algorithm selection, and evaluation. Those are all difficult to learn. So for a small and medium-sized company, how to facilitate the AI technology. Here we help them with the AutoML technology. For AutoML, we provide automatical development process, including all these steps altogether, so it can accelerate AI model generation, helping small and medium-sized company to have a lower barrier to enter this AI, to engage with these AI technologies. On the right-hand side, it's supervised learning and transfer learning. We know that we need to collect a lot of data, but once you collected a lot of data, it takes time to label. So self-supervised learning and transfer learning can help us to reduce the data labeling cost. And then once we collect the data, then we can utilize the data in a shorter period of time. Next slide, please. So another thing is the one-stop system. So in addition to AutoML, it's more focused on the developing part. We also include the operation part. So for the operation, we will acquire new data. And once you acquire the new data, we will have to update our model. And in addition to updating the model, we also have to make sure the new model, the updated model works well. So we need to have a performance monitoring in this stage. So combining developing and operation all together, the small size or medium sized company can take the advantage of AI more easily. So we develop this one-stop system, planning to develop this one, and the barrier will be much lower. So it's a low-code or no-code system. Next slide, please. So next item that I'm going to introduce a little bit is the governance infrastructure. We refer to international organizations like ISO, NIST, and French LNE. So followed by their what they have at this moment, we introduce the development part in the past few slides. So in the following, we will focus on the governance part. For the governance, we focus on privacy enhancement, data legality, and data quality, no bias, and make sure the robustness and security model. So in this one, we are going to build an AI testing and assessment center, which is focused to set up the guidelines, criterion, and standards to evaluate the risk and robustness of AI application. And we will develop the technologies and tools to measure the accuracy, fairness, and transparency of AI systems. Next slide. So as you can see from the left-hand side, there are a few international standards already, including ISO 17011, ISO 17065, and so on. And for the AI product standard, it's under developing at this moment. And so that's the international situation. And for domestic standard, AI product management protocol is not yet developed. So we will also focus on that part. And in Taiwan, so far, we only have one accreditation society like TAF, Taiwan Accreditation Foundation. So in the future, we will working with them and define the domestic standard align with the international standard altogether. So we will provide the companies the AI guidelines and the product standards will be more clear. Okay, next slide, please. So in summary, we see that the phase 1, we do achieve a lot from the past 4 years. And for the phase 2, we will focus on the a few more things, like including the advanced technologies and also the governance infrastructure. And we are hoping that with our Build AI Testing and Assessment Center, we will help the companies to better evaluate the risk, performance, and robustness. And thank you.
Thank you, Dr. Hua. And we have only one question for you. Thanks for the sharing about the current status and future perspectives of AI development in Taiwan. I think it's very important. And do you think which techniques for AI trustworthy in Taiwan should do first to cooperate or contribute to the worldwide AI society? Or which domain that Taiwan have advantage could contribute to the world? Please, Dr. Hua.
Okay, thank you. This is a very good question. I think for the trustworthy AI, it focuses actually on performance, security, robustness, fairness, and transparency. So, so for all these aspects, in terms of performance, I guess we will we will spend some time on generative AI. So in this case, we will be able to be more robustness to verify on the different environments. We can collect beta data, and in a shorter period of time, we will be able to evaluate the AI model. And also, in terms of fairness, we will focus on the bias representation learning to make sure, for example, let's say for the facial related task, different races should achieve similar performance. So we make sure there's no bias layer. And in terms of transparency, we will increase the levels of explainable AI to make sure the AI are able to explain what we wanted to know, and we can analyze the model. And in terms of the domains, I think we do in Taiwan, we do have very advanced development results for computer vision. So we can focus on, for example, the facial related application, and they can employ into financial for the ID verification. And also we can extend different domain like the self-driving applications.
Thank you, Dr. Hua. I think that's all. And we'll give this floor back to the MC. Thank you.
Okay, thank you.
Okay, thank you. Thank you, our session chair and our invited speakers. Okay, moving right on to the panel discussion. I would like to introduce our panel moderator, Professor Jian Xu from National Taiwan University, and our panelists, Ms. Elham Tabassi, ITL Chief of Staff from NIST, Dr. Yuh-Jye Lee, Deputy Executive Secretary from the Office of Science and Technology Policy, National Science and Technology Council, Dr. Wei-Bing Lee, CEO of Hong Hai Research Institute, and Mr. Andrew Shakir, Executive Director and CMO of FIDO Alliance, and Dr. Zhang Yaoling, Chief Executive of National Measurement Laboratory and General Director of CMS at ITRI. And again, we would like to take this opportunity to invite all our panelists and our honorable guests to take a group photo together for this special occasion. Now, may I invite all our panelists to turn on your cameras, and also Dr. Jonathan Xie, Ms. Karen Chang, Dr. Jang-Hwa and Dr. Wei Huang. Thank you. Do I have everyone on the screen? Looking good, everyone. Please show us your beautiful smiles. Thank you. Dr. Lin, please look at your camera at the front. Yeah, thank you very much. Okay, on the count to 3, we're gonna say cheese again. 1, 2, 3, cheese. Thank you all very much. And now I would like to hand the session over to Professor Xu.
Hi, thank you for, it is my great honor to host this panel. And after hearing several wonderful keynote speeches this morning, I think it will be an interesting time for us to get a little bit more interactive. So we would like to start the panel by asking each panelist to use 3 sentences to introduce yourself very quickly. And then I will ask each panelist 2 questions in sequence. So 1 question, 1 round, and then the second round with the second question. And then we will end the panel with a 1-sentence takeaway message from each panelist. Okay, so let's start the introduction in the order of Dr. Yuh-Jye Lee, Ms. Tabassi, and Dr. W.B. Lee, and Mr. Shakir, and Dr. Lin. Yeah, sorry for mispronouncing some of your names. Yeah.
Okay, so start from me?
Yes.
Okay, my name is Yuh-Jye Lee. Actually, I'm a researcher in artificial intelligence since early 1990. And at that time, the AI, people did not pay too much attention on it. And I also do some research in cybersecurity. And recently, I really worry about the security issue in AI system. I'm so happy we discussed the trustworthy AI this morning. I think that's a very serious problem. We have to face it. Thank you.
Okay, Ms. Tabassi.
Elham Tabassi. I am Chief of Staff for Information Technology Laboratory. That's one of the 6 labs at the National Institute of Standards and Technology. I have been at NIST since 1999. My first project was development of a open vocabulary speaker recognition, and since then I have done a lot of machine learning, computer vision with applications in biometrics. And as Jeannette said earlier today, trustworthy responsible AI has become our fascination, interest, and spending a lot of time around advancing trustworthy responsible AI. Thanks for the invitation to be here.
Yeah, thank you. And Dr. W.B. Lee.
Yeah, okay. I am a professor major in cybersecurity and also the chairman of Artificial Intelligence Foundation, a nonprofit organization. So I do really care about the topic of trustworthy AI. And I also was a government officer, so I do really know how public power can make things happen. And finally, I'm now working at the industry. So I do really worry about we will pay huge price if we provide unsecure AI-empowered services. Thank you.
Okay, thank you. And Mr. Shakir. You're muted?
Yes, this works much better now.
Yeah.
My name is Andrew Shakir. I serve as Executive Director and Chief Marketing Officer at FIDO Alliance, the industry body working to create open standards and best practices for strong user authentication. I've spent over 20 years of my career driving awareness and adoption of digital identity, both through standards groups such as FIDO Alliance, but also on the product side, where I, way back when I drove Sun Microsystems' early identity management efforts. Additionally, the topic of AI is actually quite near and dear to me, as I spent a few years more recently as an investor and executive at a machine learning startup called BigML. So I have a pretty good feel for the intersection of algorithms, predictive models, fraud detection, and biometrics.
Okay, thank you. Dr. Lin.
Hello, everyone. I'm from the TY from Center for Management Standard, ITRI, and also from the National Management Laboratories. I joined CMS MML quite early in 1985. Got the chance in establishing the National Management Laboratory from scratches and growing with MML and expanding, joint expanding activities from metrology standards to test certification or called the verification of medical device and latest to the instrumentation and hopefully the from hardware to software, something like artificial intelligence. That's it.
Okay, thank you. Yeah, so after hearing all this talk on trustworthy AI, I hope by now everybody is convinced that trustworthy AI is very important. And for this panel, I think we will zoom in on a more specific topic on testing and certification and related issues. So I would start by asking the first question to each panelist and in the same order. So start with the Yuh-Jye Lee, and please share with the audience on why AI testing and certification is important.
Okay, so I think the machine learning developed the UC database is quite important because that provide a comparison base for everyone. You know your algorithm is good or bad. But now the AI already become a commodity. So you have to let your customer know how many data you train this model, how many tests your product already passed. It's quite important. I always share my audience. There is a title in my slide called in the lab or on the field. Your model always based on the data in your hand, but you have to face a very different scenario. So your model's robustness is quite important. And if you let your consumer know your AI model have passed a lot of tests, and the benchmark data says the diversity is good enough, is very representative, in what kind of scenario your AI system can work very well. I think that will earn some trust from your customer. So that's quite important. And if we have the third party do the certification, that's even better. Just like some food or some drug, you need some certificate. So I'm so happy to know the NIST consider that kind of things. But of course, we still have to worry about the cultural difference, the different issue in different countries. Thank you.
Okay, thank you. And to Ms. Tabassi, thank you for sharing your views, your work on AI risk management. Could you share the experience of promoting the global development on AI measurements and evaluation? In particular, what are your expectations of international partners? I think
thanks for the question. I think everybody, we all share a vision in 5-10 years that the AI systems are a valid, reliable, privacy enhanced, non-discriminatory, fair, interpretable. To get there, I think it's important to globally, we all agree on what each of these terms mean. It's often the case that we use the same term meaning different things. And as I tried to explain earlier today, even terms such as bias, for a lot of community, they just think about statistical bias and not the bigger context of the bias of systemic biases, the biases that has been baked into the society, and the belief of society gets into the AI system. So internationally, it would be very good if we can, again, regardless of the cultural norm, regulatory or policy landscape, get to the same understanding of what constitutes trust, what we mean by trustworthy, unpack them into characteristics, and come to a shared understanding on the meaning of that, and then globally all work on understanding on how to measure them, right? So after understanding what to measure, work on development of the metrics, methodologies, and the right test data to measure them, because again, if you cannot measure it, you cannot improve it. So I really think that a global understanding of what constitutes trust and how to measure them is extremely important step towards actually getting into trustworthy responsible AI.
Okay, thank you. And the next question is for Dr. W.B. Lee. What are the opportunities and challenges in secure AI systems? For example, confidentiality, integrity, robustness, privacy, and so on, for industries in Taiwan, given your extensive experience in both academic, government, and industry?
Okay. But I think the challenge of putting AI in the realm of information security should be more complicated than any experience we have learned so far. And its impact on human society should be more direct, which naturally means that it will also bring more opportunities. So just as Mark Twain remarked, I love these words, this phrase, history doesn't repeat itself, but it rhymes. AI security and cybersecurity is both remarkably similar and strictly distinct. So of course, AI is the center of everything. We always say Taiwan's business people are returning to Taiwan, boosting investment in new invention and expanding investment in digital transformation. Taiwan's industry, government, and universities are all paying attention to AI. Additionally, Taiwan has benefited from the competition between the United States and China and the movement of American business to invest in Taiwan. So Taiwan has a good opportunity. However, in such an atmosphere, will anyone work on security? The attack on AI is sooner or later, and the impact is more than the impact of security on the internet now. No security, no peace of mind should be the inevitable in the future. So in recent years, cybersecurity has received more and more attention, and we have gradually moved away from the embarrassing position of being important but talk about, secondary to doing, and unnecessary when busy. So please, the people should not be so naive anymore, I hope, of course. Therefore, when everyone is concerned about benefits brought by AI, how should the elements of information security be incorporated? That cybersecurity by default or by design no longer become a game of remedy. Okay, so behind the scenes, back to the fundamental key, maybe who cares? Who are the stakeholders? Consumers, okay, they are directly affected but mostly unaware of it. Researchers, they are always trying to improve to break through the bottleneck. Expert end users, they are more concerned about accuracy. Okay, system operators, they are perhaps the most concerned, but have no voice. Okay, business teams, they do care about business functionality first. Compliance, it seems to be unresponsive. Standard organization, they have emerged, which is gratifying, especially for NIST. Really good to see the IMF for announce. Okay, advocacy groups, what can we do? Can we help? Especially for the Taiwan, the position of Taiwan. Where is the breakthrough? How to divide and conquer? How to arouse the awareness of stakeholders and open the window of opportunities? The awakening of different stakeholders will bring out different opportunities and challenges. On the other hand, Taiwan traditionally have the foundry mindset and the no market concept. So not to mention about lack of data, computing powers, and services. So how can we scale it up through cooperation in the future instead of each one fighting alone? So what about the new venture? They unfortunately do not have the scale, and that seems to lack the combination of Taiwan's advantage. So many applications of AI are contextually relevant, and Taiwan's manufacturing and medical care have excellent ecological systems. So how do we achieve consensus and work together? So in the field of AI, the situation of big country barriers have emerged, and Taiwan has to win trust first, I think. Taiwan has been recognized by information community to a certain extent in terms of integrity and quality. So an early investment in the development of secure and trustworthy AI system will give it the opportunity to grasp the global market voice and first advantage. So trustworthy AI or AI security is still in its infancy. So from technical aspects such as data and models to operational models, stakeholder management, etc., it involves various aspects of technology, industry, and society, and requires more active input and joint dialogue from cross-disciplinary talents. So seize this trend and really step out. Only then will opportunities and challenges arise and discuss be meaningful. Thank you.
Okay, thank you. And so the next question will be for Mr. Shakia. And given that many of us in the audience are not familiar with FIDO, could you give us some background on FIDO compliance as well as its work on biometric authentication and certification? How might FIDO's certification efforts relate to trustworthy AI?
Yeah, thank you. And it's really interesting to hear my fellow panelists talk about the importance of certification and standards groups. It's really great to be on this panel. So for those of you who are not familiar with FIDO Alliance, we're an industry body, a nonprofit organization that was founded about 10 years ago, actually to solve the data breach problem that still plagues us today. But passwords are very much at the tip of that spear. As you may know, passwords or knowledge-based credentials are, the cause of over 80% of all data breaches are tracked back to passwords, including more modern attacks like ransomware attacks. It all comes down to passwords. So what FIDO is doing is we're creating open technical standards, certification program, and best practices to solve the password problem. We're an industry body. We have over 250 members. They're corporate, government, and liaison members. In this membership includes, all leading device and platform and OS providers. It includes experts in, identity, security, biometrics, and also, perhaps most important, that includes a large number of leading service providers whose businesses are dependent upon the ability to have better user authentication that is not dependent on passwords, allows for safer and more secure and a better login and commerce experience. So we've been very pleased, as we've grown over the years, to see very strong presence in Taiwan. This is thanks in large part to the leadership of Karen, Chang, and Egis, who's also helped launch our Taiwan Regional Engagement Forum. FIDO's outputs include technical specifications for user authentication. These are now supported in all leading devices and platforms. And so we don't specify biometrics. You can use a local PIN, you can use a security key. The key thing to FIDO authentication is it has to happen locally on the device. It's using asymmetric public key cryptography. So our general belief is that instead of leaving authentication up to a human decision, let's take the human out of the equation and rely on the algorithm. And so whether that algorithm is based on whether the key is being activated by a local user verification with a biometric or local PIN, taking the human error out of the equation allows for an unphishable, more secure user experience. So this technology is very mature. It's in every leading device, virtually these days. It's been deployed by companies such as Google, NTT Docomo, Line, eBay, Facebook, countless banks. across Asia and the Americas. So the technology is mature, robust, and ready to be leveraged today. Now, specifications by themselves, it's kind of like one hand clapping. You really need to have a certification program so companies who are seeking to license software or hardware understand that these things conform to the specifications and that they interoperate with one another. So FIDO certification program is a key element of what FIDO Alliance does. So we have a very robust certification program that does product certification to test for product conformance and also interoperability. But we also have, some highly relevant to this conversation, emerging standardization activity. The one that's most mature is a biometric certification program. This was launched a couple of years ago, really to test the efficacy of biometric devices and components. So this is actually separate from our FIDO authentication specs. It's just testing biometric performance. And I think it's most closely related to the topic of trustworthy AI. For example, this program contemplates things like spoof prevention, intrusions, and we use, look at things like liveness detection, of course, and other best practices which can prove the integrity of a biometric process and authentication process as well. So I think that's very, very germane to this conversation today. We're also building on this foundation to launch important work for identity verification, which will include, again, there's a biometric component to that, to make sure that if we're creating standards for identity verification and recovery, that there's a strong biometric proof behind that. And when you talk about strong biometric proof, you need to think about what's the AI behind it, what's the algorithm underlying that, how do we know that it's a sound algorithm, how can we test that effectively, how do we prevent spoofs, ultimately putting trust into all the processes and all the systems. So while we do not yet have a specific focus on trustworthy AI as a specific activity, I certainly think that is something that we should put on our radar for more explicit exploration moving forward. So thank you.
Okay, thank you so much. And as the National Metrology Institute, like NIST, Center for Measurement Standards of ITRI, also known as National Measurement Laboratory, is in charge of the primary standards of Taiwan. We are very privileged to have Dr. Lin, the leader of this important institute, with us today. Dr. Lin, would you share the future vision about AI testing and certification system with us?
Okay, thank you, Professor Shi. As you mentioned, Center for Measurement Standards inside ITRI is the authorized agent in operating the National Measurement Laboratory in Taiwan. And CMS MML is the counterpart of NIST in Taiwan. So I'm glad Elham from NIST here. And we are here responsible for developing and disseminating metrology standards, measurement and testing for interoperability, usability, reliability of products, including AI-related systems. We have been involved with AI direct or indirectly with some particular areas. I just trying to give you several examples in autonomous driving, smart manufacturing, and healthcare. The first one, LiDAR, the vehicle multi-laser scanners, plays an important role in autonomous driving, and calibration the LiDAR can ensure the high precision of object detections. And the second one is the automatic optical inspection with AI algorithm in smart manufacturing. Especially, we got experience in inspecting crankshaft that are used for electric vehicle. That's part of local supply chain to Tesla. So, and the third one is about the healthcare. CMS is the only one Asian agent accredited by FDA USA, conducting pre-market evaluation of 510K medical device. And so I would like to give you the third one example in computer assisted detection in diabetic retinopathies. It means the diabetes can be detected, diagnosed in early stage through quality fundus cameras. And To do that, we must ensure the safety effectiveness of the funders' cameras can be verified through its AI or machine learning softwares. So basically, based on the successful experience above in medical device manufacturing, autonomous driving, and even the photovoltaic power stations, we aim to create the local AI measurement service in a more systematic and comprehensive ways, which will be harmonized with global partners such as NIST and her AI risk management framework, which Elham has mentioned and presented a very good presentation. Hopefully, it could benefit export, Taiwan's innovative application from industry, and also that will be a contribution to academic users and the governments. And thank you.
Okay, thank you, Dr. Lin. And I would like to take this opportunity to thank all the panelists for the first round of questions. And before we start the second round, I would like to invite Dr. Yuh-Jye Lee to give us a few sentences, because during the pandemic, many important people developed the ability to multitask. And so he has to move to another meeting in a few minutes, but he would like to share a few sentences before he has to leave. Okay.
Okay, thank you so much. Because the next meeting is a physical meeting, so I need some time to do the transportation. And actually, I'm very excited to see the AI development. When I was a graduate student, we are doing mathematics, we doing AI, but we don't see any real world applications. And now is a great moment for the research have been AI community for more than 20 years. That's a very exciting moment. But human will make mistake. AI system will make mistake too. But I believe that the human mistakes are more randomness, but AI is more systematics. Once we find a bug, then we can improve the system and make a big jump. So I'm still very believe that AI will have a very great futures, but humans have to be very careful to select the technologies. And I try to make that kind of noise. The facial recognition technology is mature, but you cannot always apply this technique everywhere. And another thing is when you see something is very fancy, then you have to be very careful the risk behind this new technology. So I believe that we are mature enough in AI technology, and this is the right moment we consider the trustworthy AI. And I always be very positive when we consider the trustworthy AI. We bring more constraint to the real world usage. We consider more. That will make we break through the technology. That's also good news for researcher. Thank you. I'm so sorry I cannot finish the entire workshop, but I'm enjoying very much. Thank you.
Well, thank you, Dr. Lee. And
bye-bye.
Bye-bye.
Sorry. Bye-bye.
Bye-bye. Okay, so we are moving on to our second round with our distinguished panelists, and we will be back to Ms. Tabassi. And given your leadership at NIST Trustworthy and Responsible AI program, would you please suggest the top priority target applications or industries, from your views?
Right. So the work that we had done for the AI risk management so far, it's rather in standard lingo, horizontal or technology agnostic. So we're trying to basically build the building blocks that the trustworthy, responsible for the different contexts, for the different use cases can be built on. The applications that are most important, I would say that would be applications that's going to affect our daily life most, right? Applications such as, for example, using of the AI for hiring, that's the future of our, building careers, building life. Application of AI for healthcare, again, during the pandemic, we have learned that how important it is to be able to forecast and predict the next pandemic and where these things start. Given everything that's going around the world and the planet getting hotter, so the climate change, all of the applications of the AI for social good and that can enhance the daily lives and make a better life and give a better planet to our children. I think that's going to be very important.
Okay, thank you, Ms. Tabassi. And next question is for Dr. Weibing Li. We understand that it is very important to develop trustworthy AI in line with international standards. How should Taiwan establish an industrial ecosystem with global organizations and enterprises?
Okay. So the first, we must understand that the new rules of modern disruption are ecosystem disruption. Okay, so that's very important. As Taiwan is small, so it's important to make the base plans with the limited resources and to form proper consensus in the industry. So in implementing industrial development strategies, Taiwan needs to consider two different paths, vertical deepening and horizontal expansion. The key to combine with the existing strengths, enhance local added value, and improve long-term competitiveness in a comprehensive manner. So where to start? I don't really have a clear answer because it's a huge problem. So, but all I know is that international cooperation requires creativity or even goodwills and above all, strength. So it's not enough to rely on hard power alone, but also sometimes we say that soft power must be added in a timely manner and perhaps a smart power. They combine the most, both hard and soft is the key to our real influence. So what do we have is very important. Do we have the consensus? Is there a rally of forces? What does the ecosystem of fight means? So such an effort requires collaborations among government, industry, academy, and even non-profit organizations. And Taiwan's next step in AI development is of great interest to Asian countries. For example, the NPOs in Singapore, Korea, and Australia have invited the Artificial Intelligence Foundation to jointly plan the Asia-Pacific framework on using AI, hoping to jointly advocate the use of AI to reshape the global industrial landscape and define new advantages of Asian industries. Also, in the past years or so, Hon Hai Research Institute has actively played the role of connecting with international industry and academy while contributing to the foundation of the Hon Hai Group's R&D and laying a good foundation for the security of the Hon Hai Group's AI services, both internally and externally. So to identify where the strengths lie, we must have a consensus. We must be willing to share and make use of our strengths so that Taiwan's strengths can be shown or developed. Only then will it be meaningful to establish an industrial ecosystem with foreign institutions or enterprises. Again, Taiwan needs to win trust first to build industrial resilience and business opportunities. So raising security awareness, building trust in Taiwan's brand, and knocking on the door with strength may be important keys. After all, information security is difficult to prove. So there are a lot more complicated AI security or even trustworthy AI. I believe that trust is the most important value, and the stress is the guarantee of the value. So knowing ourselves is essential for success, and it could be the good starting point. Thank you.
Okay, thank you. Mr. Shakir, as you presented earlier, under the leadership of Karen Zhang, Taiwanese government and many industries, such as the financial sector, have actively adopted the FIDO standards. So what are your recommendations for future collaborations in the area of trustworthy AI?
Yeah, one of the nice things about standards bodies like FIDO Alliance is that the focus areas and outputs of our body are determined by its participants. Everyone has an equal say. Everyone has a vote, if you will. So we're very fortunate to have the Taiwan Ministry of Interior as a member of FIDO Alliance. And of course, one of the reasons why we launched the regional forum in Taiwan is to make sure that we both gather regional requirements, from the Taiwan region, but also to provide resources and information to help local industry succeed with their FIDO work. So I think it's really important for us to engage locally to help industry be successful with FIDO authentication and related AI implementations. Additionally, we have function-specific deployment working groups within FIDO Alliance, where Taiwanese industry is encouraged to take part, including a consumer deployment working group, where experiences and perspectives from, say, the financial sector will be welcomed. We also have a government deployment working group, which Ms. Chang chairs or co-chairs, where we get government use cases brought in as well. So I think that as we look at how FIDO is shaped, and we look at the current and emerging requirements in the Taiwanese market, there's a very good fit there. One last thing to note is that, as you may know, FIDO Alliance will be holding one of our 3 member plenaries in Taipei of next year. So I'm very excited for this. It's been delayed now for around 2.5 years due to COVID and other reasons. So we will be there in early February of 2023. I'm very much looking forward to the member plenary and also to a public seminar that will be holding that same week. And I hope that we can use this visit, where we'll have so many stakeholders from FIDO Alliance in Taipei, to foster deeper engagement with the Taiwanese technology, government, and industry communities.
Well, thank you. It is great to know that Taiwan will be so deeply engaged in all your future activities. And to Dr. Lin, given that you are leading the top authority on national standards for measurements, what could be the strategies for Taiwan to develop the AI testing and certification system, which will be internationally recognized?
Okay. Actually, CMS MML is celebrating the 35 years anniversaries. So in the past 35 years, we have joined or built up the link with international professional society. For instance, in metrology, MMI, networkings, International Committee for Weights and Measures, CIPM, in brief, has signed the mutual recognition arrangement. We call it the CIPM-MRA with major countries and economies. And Taiwan signed that in 2002. So by this kind of CIPM-MRA, MMI, and can demonstrate the international equivalence of their measurement standards and calibration measurement certificates they issued. So for instance, there's a link between CMS, MML, and NIST. And also the MI allows all the assigned members to facilitate international trading through qualified calibration and measurement capability. The second one, as part of the attendee as mentioned, the standards platform. Besides the official standardization platform like ISO, IEC, or in medical device, there's one called Global Harmonization Working Parties in healthcare. CSMM has joined. And in particular, I would like to mention that some influential and particular industrial platform, for instance, Semiconductor Equipment Materials International, is very important in semiconductor factories. Taiwan with the strength in semiconductor industry and can have significant contribution to this kind of a platform like SEMI. Those are just a good example of participating in the global framework by our technology advantage. So in brief, we expect to extend Taiwan's good networking in metrology and standards to test and certification or verification in healthcare, ranging from specific area like chip industry to AI certification. There are several, like NIST, AI, IMF, or FIDO, Andrew just mentioned. So I think just some source on the linking with the international society. Thank you.
Okay, thank you, Dr. Lin. And I think this has been a very informative panel from the perspective of NIST, FIDO, as well as different agencies and industries in Taiwan. So I would like to have the last opportunity for all the panelists to share your key takeaway message for the audience. And I don't know if we should do by the order, or does any panelist wants to jump in? Okay, if nobody wants to, cut in the line, I will still go by the same order with Ms. Tabassi.
I would thank you. Excellent presentations. I would summarize takeaway, but by also sort of my wishes that what we need to do is operationalizing values. We want to build technology that are rights preserving by design and not make the risk management or trustworthy responsible AI as a afterthought. And we have to do this carefully and sort of in a very scientifically valid manner, because there's a lot of pressure to do it fast, but we should pay a lot of attention and focus on trying to do it right, but also don't take too much time, because the risk of the AI are real and their benefits are enormous. And what we want to do is get the enormous benefits. So a call out to all of the, Jeannette, call out to the statisticians and people working in formal method, but to every scientist, subject matter experts, from computer scientists to mathematicians, statisticians, but also sociologists, psychologists, lawyers, to think about how to operationalize values and build technologies that are rights preserved.
Okay, thank you. And Dr. Weibing Lee.
Yeah, thank you. I think that no trust in the smart power, the opportunities we set are the mirage. So to build trust and stress, we must first understand ourselves and come to a consensus, especially for in Taiwan. And of course, finally, teaming together. Thank you.
Okay, thank you. That's very important. Okay, and Mr. Shakia.
Yeah, I'll be brief. First of all, thank you so much for having me on this panel. It's really an honor. So one takeaway for everybody is to deploy FIDO authentication today. And then also, to protect your enterprise, protect your customers, protect your employees, protect yourselves. Stop depending on passwords, and we have good technology you can use from a variety of vendors. But also, please do get involved in our standardization efforts as members or through the regional engagement forum in order to make sure that all these perspectives we're talking about today and that people who are viewing have themselves are ultimately reflected in FIDO Alliance's outputs. Thank you.
Okay, so maybe I would like you or Karen to share the contact information for getting in touch with the FIDO Alliance Taiwan Regional Forum. And that will be very helpful for all the audiences today. Okay?
Okay.
Yeah. Also, to Dr. Lin, any takeaway message for the audience?
Okay, thank you. So I will use the phrase just scarf outside the CMS buildings. It's by one of the past general director of CMS. It's called Metrology for Qualities and Standards for Harmonization. That stating the spirit of metrology standards and standardization. So CMS MML hope to inside the ITRI hope to be all the partner in trustworthy AI. That's it. Thank you. Yeah.
Okay, thank you. Yeah, I think we all understand that it is super hard to define standards for software, let alone AI software, because it's even more complex and it involves the data, the model, and a lot of the different domain information. So I think it's definitely a very important thing for all of us to work together at the beginning stage, and so that we can move toward trustworthy AI. Okay, and I would like to thank all the panelists for your valuable sharing today, and thank all the audiences for staying for the workshop. And I hope you all enjoyed the presentations and also learned a lot of the information that will be super important for doing better work. Okay, thank you. Okay, thank you, everyone.
Thank you, Professor. Thank you, our panelists, for such a wonderful discussion. And I would like to thank you, all our audience. Thank you for staying with us the whole 3 hours. We have come to the end of the workshop. And now our co-chair, Dr. Wei Cheng-Huang, is going to give his closing remarks. Dr. Huang.
Okay, so ladies and gentlemen, thank you for staying with us for more than 3 hours. And today, I think we have fruitful takeaways from the keynote and the future session that we need to work together, and we will work together to be able to tackle the challenges of AI before we can enjoy the benefit of it. And we also learned from the panel session that the testing and the evaluation of AI is a crucial part of the whole picture. So this workshop is just the beginning of our efforts. Keep in touch and see you soon and next year. Have a good day and good night. Thank you again.
Thank you, ladies and gentlemen. Have a good day and good night. See you again.